Okay, today's note session is going to be about acceleration. Acceleration is another way that we can describe, another term that we use to describe motion, and it is also based on mathematics because we took a look at how we can describe motion either using words or using math, and we found it was much easier to use math. So one of the ways before that we had described motion was by talking about speed or velocity. Speed being how far you went in a certain amount of time, or how fast you're going, your rate of movement. Velocity is the same thing except for with a direction involved. Now we're going to take a look at another descriptor of a motion, which is acceleration. And acceleration is how your velocity is changing. So how is your speed changing? How is your direction changing? We can also use a mathematical equation to define acceleration. Acceleration is equal to the change in velocity over the change in time. So we usually use A to represent acceleration, delta V for change, that little delta, Greek delta sign, means change in velocity over time. So how do we find the change in velocity? It's really our final velocity minus our initial velocity. So sometimes, depending upon your science textbook, they'll use VF and VI for final velocity and initial velocity. Sometimes they'll use V1 and V2, where 2 is the final velocity and V1 was your initial. This was my first velocity, this is my second velocity. So depending upon which book you have, I just wanted you to be aware of the variations that you might see. So if we have a car that's changing from 0 to 60 miles per hour in 6 seconds, you go to buy a car and the salesman's always like, oh yeah, this car can go from 0 to 60 in 6 seconds. Ooh, you know, everyone's excited about that. What's he really talking about? He's talking about how fast it can accelerate, which is usually a parameter of how powerful your engine is. So if I'm sitting at the light at the Walmart and some little old lady is like rolls down her window and says to me, you want to go? I'm like drag race? And she's like, sure, let's go. And she has a Thunderbird and I have a Viper. Her Thunderbird can go from 0 to 60 miles per hour in 6 seconds. And what that's basically saying is if the light turns green and she puts her pedal to the metal, her car will begin to accelerate, change. There'll be a change in velocity over time. After the first second, she's going to go 10 miles per hour. After 2 seconds, she's going to go 20. After 3 seconds, she's going to go 40, and so on, until after 6 seconds, if she's been traveling for 6 seconds, she's now going 60 miles per hour. So her speed has increased by 10 miles per hour for every second that she went. This is her rate of acceleration. She went 10 miles per hour per second is her acceleration rate. She's changing by 10 miles per hour for every second that she goes. Unfortunately for her, I'm driving a Viper, which can go from 0 to 60 in 3 seconds. So after the light turns green and after 1 second, I'm going 20 miles per hour. After 2 seconds, I'm going 40 miles per hour. And then after 3 seconds, I'm going 60 miles per hour. So my acceleration rate is 20 miles per hour per second. And of course, because my acceleration rate is much greater than hers, I'm waving to her in my rear view mirror and I can see that she's lipping something that doesn't look very nice, not very friendly. Okay, something like some sports cars can go even faster than that, but that's usually, you know, the fastest acceleration rate. And again, we said that has something to do with your horsepower. So if again we wanted to take this phrase and figure out her acceleration rate, we could take the final velocity, which is 60 miles per hour, minus my initial velocity, which is 0 miles per hour, divided by the time that it took. So it's 60 miles per hour divided by 6 seconds is 10 miles per hour per second. Now notice my unit here is a velocity unit divided by a time unit, and my time units do not have to be the same. So acceleration is a rate of change of rate. So you will have 2 units, and as we said, they need not be the same, miles per hour per second. If we do have 2 time units that are the same, we can square them. So if I have meters per second, I can call that meters per second squared. Now, deceleration is a type of acceleration. It's when I am getting slower. I'm slowing my final velocity is slower than my initial velocity. In our acceleration example, our initial velocity was slower than our final velocity. We were speeding up. In a deceleration, we are slowing down. Okay, so really this is a type of acceleration. It's a negative acceleration. So if you're doing an acceleration problem and you get a negative number, that's okay. It simply means that you're slowing down rather than speeding up. Okay, so when we get back to the classroom, what we're going to be doing is working on some acceleration problems and seeing how well we are capable of doing that, and seeing how well we understand the concept of acceleration.